Professor. My name is Mahesh Mervu. I'm here to present my project which I have done on EmbOS RTOS and ThreadX RTOS. So I'll take you through this uh, presentation and I will explain you everything in detail. So coming to the introduction of EmbOS RTOS and ThreadX RTOS. EmbOS is an unique embedded operating system designed for real-time applications on variety of microcontrollers with priorities control multitasking. It meets the limitations of microcontroller with its fast speed, flexibility, and lower memory consumption in both RAM and ROM. And coming to the ThreadX RTOS, which is it is a very well-known real-time operating system. ThreadX, it is very well known for its minimal memory footprint. It was created for embedded systems for effective task management. It provides priority-based scheduling in conjunction with preemptive multi-threading. ThreadX guarantees speedy operation in highly interrupt-driven context with its quick handling of interrupts and resource management. So moving forward with the other slide, which will tell you more about the historical perspective of EmbOS RTOS and ThreadX RTOS. The design EmbOS RTOS was designed for real-time microcontroller applications. Stager microcontroller created it in late 1990s. Early iteration prioritized memory efficient multitasking that was controlled by priorities. And coming to the ThreadX RTOS, it was initially um, created for embedded systems and Internet of Things devices by Express Logic in the late 1980s. Early iterations placed a higher priority on fundamental real-time features like priority-based scheduling and preemptive multitasking. Increased feature set over time in response to embedded system developers' changing needs. So moving to the third slide, which is goal and purpose of EmbOS RTOS and ThreadX RTOS. These are the two most popular real-time operating systems for embedded systems and Internet of Things. EmbOS' primary goal was to cater to all the embedded systems, and ThreadX, which was created by Microsoft, um, which has been initially under Express project and acquired by Microsoft Azure RTS. It both had the goal of improved synchronization methods and priority control multitasking with low memory consumption. So EmbOS supports a variety of control architectures. Mm, It is including with electronics, healthcare, and automobile industry. ThreadX, while it's known for minimal tiny memory footprint, deterministic performance, and simplicity of integration, offers preemptive multitasking with priority-based scheduling. So moving on to the other slide, which is standard platforms governing this EmbOS RTS and ThreadX RTS. So many CPU architectures such as 8-bit, 16-bit, and 32-bit processors are supported by EmbOS because its support is well known for CPU families like ARM, RISC, AMD, Intel, and power it may be applied to a wide range of embedded devices. Whereas ThreadX RTOS, the precise CPU architecture and the hardware platforms that ThreadX RTOS supports are not covered in detail by search results, and advanced RTOS that's tailored for embedded IoT applications is how ThreadX been described, and that's the goal it has achieved. Yeah. Moving on to the other slide, which will tell you more about evolution of EmbOS RTS and ThreadX RTS. Okay, EmbOS RTS first version, which was introduced in late 1990s to early 2000. It was the first version which primarily focused on design, stressing efficiency, probability, portability, and dependability. These early version introduced key features including task scheduling, synchronization, preemptives, interrupt handling, and memory management. The second version, though it came in late 1990s to 2000, it was based on the human feedback and the new development. It consisted of better synchronization mechanism and guidance for additional microcontroller architecture. The third version, was came in early to mid 2000s, it was further optimized and improvements were seen of the RTOS core. The fourth version, which was introduced in mid 2000 to late 2000, it was constantly adding new features and support for excellent communication protocols and network capabilities. The fifth version was a major milestone in itself. It introduced real-time monitoring and profiling features for performance evaluation. The sixth version, which is the latest version until now, is was introduced in early to mid 2010s, and it was for excellent memory protection mechanism. Whereas for the ThreadX RTOS, the first version, which is from version 1 to 2x, was introduced in late 1990s to early 2000s. Uh, it likely to be focused on core real-time capabilities such as preemptive multitasking, priority-based scheduling, and efficient interrupt handling. Um, ThreadX 3.3 version to the fourth version, which was introduced in early to mid 2000s, it saw significant updates and enhancements to meet the growing demands of embedded systems. New features such as communication protocols, file system support, and enhanced debugging and profiling capabilities. The fifth version, which was introduced in mid 2000 to late 2000s, Mm, this version may have introduced advanced capabilities such as real-time tracing and profiling, allowing developers to analyze system view in greater detail. The sixth version, which was introduced in late 2000 to early 2010s, it added new features while optimizing the current features, and added security features such as support for encryption authentication protocols. The last one is the latest one, is the seventh version, which is meets the latest challenges, and it also incorporates the AI in it. Going on to the next slide, which is where we'll learn more about hardware platform, where EmbOS and ThreadX RTOS are used. First, going with the EmbOS RTOS, it is um, used primarily with um, array, with most of the things such as ARM, Cortex-M, Renesas, RX, and others. So the first one, which we see the picture over here, is ARM Cortex-M. Okay, um, in that you can see it has been used over there, and the Renesas RX EmbOS offers support for that microcontroller families as well. Okay, and that microcontroller is being used in automotive, industrial, and consumer electronic application. The other one is micro chip PIC32. EmbOS uh, is compatible with microchip's PIC32 microcontroller series, and it is also very popular in consumer electronics, medical devices, and automotive systems. Mm. The other one is uh, the Texas Instruments MSP430 as well. It supports Texas Instruments MSP430 microcontroller family, known for its ultra-low power consumption and high performance per watt ratio, which you can see in the coming slides as well. Coming to the ThreadX RTOS. So here we can see there are other very good, um, several other things which is being used for. Okay, the first one is ARM Cortex M series. Okay, it's been used for other series of that family like Cortex M0, Cortex M3, Cortex M4, and Cortex M7. Then the next one is Texas Instrument MSPP 430 series. The picture you can see, the red one is the same one. So this macro, it is compatible with all those microcontrollers, and it is family known for ultra low power consumption, making it suitable for battery powered and energy efficient applications. Mhm. And going to the other slide, which will show you more where there it is being used. So ThreadX is also used in Renesas RX series, which is popularly used in automotive, industrial, electronical applications. Apart from that, it has also been used microchip PIC32 series, which combine performance of MIPS architecture with ease of use of the MIPs of PIC microcontroller family. The next one is NX PLPC series, which you can see the photo over there. This microcontroller is offers a range of performance levels and peripheral integration options, making it suitable for diverse applications. The last one is STM microcontroller electronics and STM32 series, which are popular for industrial, automotive, and consumer electronic applications. And you have also a picture for that which you can refer, and you can understand how it looks in real life as well. the next slide. Moving on to the next slide. So this is one of the most important slide I would say in this whole PPT presentation to understand the comparison between these two OSs. The first comparison, you know that, right? These both are very well known RTOSs for embedded devices and ThreadX, but they have different architecture, license, ecosystem designed for devices with limited resources. Okay, so first difference that I would say is like, you know that the developers for EmbOS was such a microcontroller, um, whereas for ThreadX it was earlier Express Logic, but now it's Microsoft Azure RTOS. The second difference was is EmbOS is noted for efficiency, mobility, and minimal memory, whereas ThreadX is noted for deterministic real-time uh, speed and minimal footprint architecture. It's like EmbOS is flexible and tailored to resource-constrained embedded devices, whereas ThreadX is preemptive multi-threading, priority-based scheduling, efficient interrupt handling, licensing options also. EmbOS is commercial evaluation, royalty-free resource code, whereas ThreadX is commercial with pricing based on developers, deployment units, and support packages. Ecosystem EmbOS is comprehensive documentation, development tools, and support resources, whereas ThreadX is substantial documentation, training materials, and support services. And development tools seamlessly, EmbOS seamlessly integrated with Sage's software development tools, whereas ThreadX works with wide variety of development tools and hardware platforms integrated with Microsoft development tools. Moving forward to the other slide. So the user critic for EmbOS RTOS was efficiency and performance. Efficiency and performance. EmbOS is widely recognized for its performance and its efficiency, but uh, obtaining a peak performance may necessitate careful design and optimization of EmbOS, particularly in constrained systems with limited memory and computing capacity. Documentation and support. Uh, Center support team is noted for its quickness and experience, giving prompt assistance. However, some users may think that additional examples or tutorials covering specific use cases would be improve their learning experience. Portability and integration. While EmbOS is mostly compatible, users may experience occasional compatibility issues with certain hardware or development tools. Feature set. Now, some users have noticed that EmbOS lacks advanced capabilities available in other RTOs, such as built-in support for complex communication protocols, file systems, and so on. Licensing and cost. Um, there are users that think that the pricing of the EmbOS for commercial licensing is very high compared to other RTOs, and the community and the adoption. Like very few people have been using this, so that community is not that strong. So discuss all these issues if they have. Whereas ThreadX, it is known for its deterministic real-time performance um, because of its priority-based scheduling algorithms, small footprint, um, which is due to its limited resources such as microcontroller with constrained RAM and ROM. Documentation support is excellent for them. Portability and integration has never been a concern for them. It is well set with all the features and everything. Licensing and cost is also very suitable for everyone. It's very flexible. The adoption from the community is also very super for ThreadX RTOS. So moving to the next slide, which is the architecture or the design and implementation of EmbOS RTOS. So the EmbOS RTOS consists of a kernel which oversees delivering essential real-time operating system functions, and the second one is the task management, which oversees all the um, processor processor running numerous tasks simultaneously thanks to its multitasking capability. And the third one is scheduling, which is preemptive priority-based scheduling used by EmbOS RTOS. And the fifth one is synchronization and communication. To promote interaction between tasks, EmbOS RTOS offers synchronization communication features. Then handling interrupts is also an important part of the design and implementation. Memory management to dynamically allocate and deallocate memory during the runtime. The RTOS offers memory management functions. The last one is timer management, which is used to manage the sensitive task very efficiently. Now, moving on to the next slide. So, inter-thread RTOS, inter-thread communication, which is properly there in this system. Okay. Then the second one is uh, the memory management, which is used for memory pools by ThreadX memory management to effectively dynamically allocate and deallocate fixed size memory blocks. Um, then there is uh, thread thread synchronization, which is provided by the uh, which is ordered to manage the shared resources and avoid race situations. And then there is timer services, which were offered by ThreadX to make it easy to precisely schedule and carry out tasks at predetermined intervals of time or timers. The last one is ThreadX core management, which is the key or component of ThreadX architecture and task management. It generates plans and carries out threads while overseeing task control blocks. Now going to the other slide. So we're going through different types of EmbOS RTOS. The first one is the EmbOS full version, which offers all the necessary features of RTOS. Then the second one is the EmbOS Tiny Edition, which is a smaller version which only offers width for limited memory and processing power. Then there is the Safe RTOS, which is specifically tailored for developing safety critical embedded systems that require compliance with industry standards. Then there is an EmbOS for ARM Cortex, which is customized and tailored for microcontroller architectures primarily based on ARM Cortex M. And then there is EmbOS or Renius RX, which you can refer the picture, which is that's how it looks in real life. And then you have EmbOS POSIX edition, which is the POSIX stands for Portable Operating System Interface, allowing developers to port POSIX compliant applications to embedded system running on EmbOS. I'm moving to the other slide. So the types of ThreadX RTOS is the standard edition, which is provide all the standard pro essential real-time features of the RTOS. The second one is the advanced edition, which has advanced capabilities than other than standard edition, like real-time features such as message queues, event flags, memory pools, and thread priority inheritance. The certified edition, which is a tailored version for developing safety critical embedded systems that require compliance with industrial standards such as DO178C. And then you have FileX file system, which provides a high performance file system that supports FAT12, FAT16, FAT32, and exFAT formats. Now moving to the other slide, which is categories of EmbOS RTOS and ThreadX RTOS. So we have four categories of EmbOS RTOS. One is EmbOS Ultra. So it is simple, useful, and ensures that any embedded system can run that one. The EmbOS Ultra, which is for unmatched precision. EmbOS Ultra includes cycle resolution timing, which allows scheduling in microseconds or CPU cycles for time-based events. Then comes EmbOS MPU, which is provides memory protection on top of a well-known RTOS EmbOS. Then the EmbOS Safe, which is has clients protected thanks to strict compliance with IEC 6158. And then we'll go to ThreadX RTOS, which is different type of ThreadX. RTOS one is ThreadX SMP, ThreadX and NetX, ThreadX FileX, ThreadX TraceX, and ThreadX MCU and ThreadX Lite. Going to the next slide, features of EmbOS RTOS. The first feature is time resolution is adjustable and the default is 1 millisecond and easy available time variable. Preemptive scheduling ensures that the highest priority job in ready state is executed unless priority inheritance occurs. Round robin scheduling for tasks with same priorities up to uh, 4 billion priorities. Tasks can have individual priorities, allowing for exact responses based on application needs. Supports unlimited tasks, software timers, and communication primitives as events, objects, and semaphores, mutexes, mailbox, and queues. Now, the other features of ThreadX RTOS are it's like simple Pico kernel architecture, lightweight and efficient kernel design for streamlined operation, automatic scaling, and the other one is complexity and cost of implementation. Factors affecting that contribute to complexity um, is feature set. The features needs to be takes it to the next complexity. Configurability. The more you configure, the more complex it becomes. Concurrency management, which refers basically to uh, multi-threading environments, adds complexity to the RTOS. Then there is real-time requirements, interrupt handling, batch is known for um, meeting requirements, adds complexity to RTOS. And then memory management, scheduling algorithm, portability, safety critical requirements, and integration with other systems. Um, there is other factors that are affecting cost, which is licensing model, addition and features, support and maintenance always cost money, development tools and ecosystem, training and education, scalability and deployment size, customization and integration. Now, coming to the pros and cons. Pros of EmbOS RTS, it's like very efficient. It's a real-time performance, scalability, flexible license, comprehensive feature set. And the cons of um, Pro EmbOS RTS is documentation and support, learning curve, limited ecosystems, safety critical compliance, integration difficulties. For ThreadX RTOS, it's improved responsiveness. The pros are improved responsiveness, software maintenance, increased throughput, processor isolation, dividing the application, improved time to market, protecting your software investment. Cons are dependence on middleware, cost, vendor lock-in, limited debugging facilities, real-time guarantees. Companies using EmbOS RTS majorly are uh, uh, Sager microcontroller, Audi, Bosch, ABAB, and the company that are using ThreadX RTS are Microsoft, and it's Canon, Siemens, Samsung, Philips, and the last slide which we are going to move forward is future trend of EmbOS RTS and ThreadX RTS. So first with EmbOS RTS diversifying to new industries. They're trying to penetrate into new industries apart from only electronics and in um, automotive, improve network and connectivity, emphasis on energy efficiency, safety critical applications, integrations with AI and edge computing. The other one is ThreadX RTOS, which is uh, integration with edge computing and IoT, uh, enhanced security measures, support for AI and machine learning, real-time performance optimization, expansion of ecosystem and partnership. And finally, to conclude, to sum up, EmbOS RTOS is one of the and ThreadX are industry mainstays in field of embedded systems, each with special advantage and skills suited to various industrial demands because of its effectiveness, small size, and quick response time. EmbOS RTOS is preferred option for applications with little resources. In meanwhile, ThreadX RTOS shines thanks to its strong Pico kernel design, predictable performance, and wide range of ecosystem support. It is especially well suited for intricate IoT deployments and systems that are vital to safety. Thank you for being there with me this whole presentation, and I hope if there's any doubt, you can contact me on my email ID. And uh, I hope you understood all the project that I have done in this by this presentation. Thank you.